Welcome everyone. Today we are showcasing the future of farming. These advanced autonomous drones are ready for deployment.
In today's video, we're diving into the tools, workflows, and real costs behind drone-powered large-scale farming. We'll cover the drones, sensors, software, ground crews, and the economics that make it possible for one person to oversee up to 10,000 acres. And stick around until the end. I'll walk you through a real daily workflow and reveal the single most important metric you need to track if you want this system to actually pay off. Fast cuts of drones spraying fields, colorful multispectral maps loading on screen, autonomous tractors moving through rows, and analytics dashboards updating in real time. Traditional large-scale farming depends on huge machines, long hours, and large crews. Drone farming changes that equation completely. Instead of treating every acre the same, drones let farmers target exactly where attention is needed. That means faster scouting, smarter spraying, and near real-time field insights. The results can be huge, scouting up to 10 times faster, reducing wasted spray by as much as 70%, spotting disease earlier, and scaling operations without scaling labor. With the right setup, one trained operator can monitor multiple drones and machines remotely from a single dashboard. Fixed-wing drones are built for endurance and can stay airborne for 2 to 4 hours, making them perfect for covering massive acreage. Quadcopters, on the other hand, are better for close-up inspections and detailed scans. Their job is to create high-resolution orthomosaic maps, terrain models, and LiDAR scans that reveal exactly what's happening across a field. Features like RTK and PPK positioning push accuracy down to the centimeter level. Fixed-wing drones are built for endurance and can stay airborne for 2 to 4 hours, making them perfect for covering massive acreage. Quadcopters, on the other hand, are better for close-up inspections and detailed scans. Their job is to create high-resolution orthomosaic maps, terrain models, and LiDAR scans that reveal exactly what's happening across a field. Features like RTK and PPK positioning push accuracy down to the centimeter level. These drones don't just collect data, they take action. Sprayer drones apply fertilizers, pesticides, and biological treatments with incredible precision. Depending on the setup, payload capacities range from around 10 liters to over 50 liters. Features like droplet control, obstacle sensing, and RTK-guided flight paths help reduce drift and improve accuracy. Many systems also use stabilized spray booms and low drift nozzles for safer, cleaner application. Drones are powerful, but they're not replacing every machine on the farm. Autonomous tractors and robotic ground vehicles still handle heavy-duty tasks like seeding, tillage, and hauling. In many operations, drones scout the fields first, then autonomous machinery carries out the actual intervention. This is the command center. Cloud-based planning tools schedule missions, manage airspace, monitor weather, and coordinate multiple drones at once. Features like geofencing, automatic return to home, and reusable mission templates make large operations far easier to manage. Once the drones land, the real data work begins. The software stitches together thousands of images, calculates vegetation indexes, detects weeds or pests, and even helps predict yields. One smooth workflow looks like this. The drone lands, files upload automatically, cloud processing starts, and within minutes the system flags problem zones that need attention. This is where raw data turns into action. The software creates prescription maps for variable rate spraying or fertilization, meaning different areas receive different treatment levels based on actual need. These files can be exported as shapefiles, ISO-compliant rasters, or sent directly into sprayer systems. This is where raw data turns into action. The software creates prescription maps for variable rate spraying or fertilization, meaning different areas receive different treatment levels based on actual need. These files can be exported as shapefiles, ISO-compliant rasters, or sent directly into sprayer systems. Before sunrise, automated thermal missions launch to detect overnight irrigation issues or temperature stress. By around 8 a.m., processed maps are already waiting in the cloud dashboard. The operator reviews flagged areas and generates prescription maps for targeted spraying. Instead of treating an entire field, the system focuses only on the zones that actually need intervention. Sprayer drones execute variable rate applications while ground crews or autonomous tractors handle heavier tasks nearby. The whole operation becomes more coordinated, precise, and efficient. At the end of the day, data syncs back to the cloud, batteries are swapped, maintenance checks are completed, and tomorrow's missions are scheduled. Drone takeoff gives NDVI maps turning healthy green, gives sprayer flying perfect grid lines, gives tablet checklist filling with check marks. Even with automation, skilled people are still essential. Typically, one operator handles flight planning and monitoring, while a small ground crew manages batteries, maintenance, and logistics. Commercial drone operations also require proper certifications, safety procedures, and emergency planning. Depending on the country, pilots must follow airspace rules, pesticide regulations, and buffer zone requirements. Modern systems add extra protection with geofencing, parachute recovery systems, redundant RTK positioning, and secure communications. Let's talk numbers. A professional mapping drone can cost anywhere from $10,000 to $50,000. Multispectral sensors typically range from $5,000 to $25,000. Sprayer drones often fall between $15,000 and $60,000, while software subscriptions can add another $2,000 to $15,000 per year. Then there's support equipment, batteries, chargers, transport vehicles, and maintenance gear. But the payoff can be substantial. The biggest reward drivers are reduced fertilizer and pesticide waste, faster problem detection, lower labor costs, and better yield protection. On a $10,000 operation, precision spraying and irrigation optimization can reduce wasted inputs by 20% to 40%. Depending on crop value and operational scale, many farms recover their investment within 1-2 growing seasons. Drone farming isn't magic, and it's not without challenges. Weather still matters. Wind and rain can delay flights or reduce spraying accuracy. Battery limits and payload capacity can also slow down non-stop large-scale operations. There's also the challenge of integrating new drone systems with older farm equipment and software, and regulations vary widely depending on where you operate. Most importantly, drones don't replace farming expertise. They amplify it. If you enjoyed this breakdown of how one person can manage 10,000 acres using drones, hit subscribe and ring the bell. I post deep dives into farming technology every single week. And let me know in the comments what surprised you most, the savings, the technology, or the sheer scale of these operations.